So good morning, everyone. I'm Audrey Rousseau, President and CEO of the Pittsburgh Technology Council. I am always thrilled to kick this off. Today is Thursday, our 8th day of the STEM Summit, and we are absolutely excited each and every day, and today is no different. We are going to explore Philips Healthcare, who has a pretty big presence in Pittsburgh, Pennsylvania, and you're going to have a chance to hear from some amazing people. They are one of the most impressive companies that are just sitting right outside all of our doorsteps, and they've been a sponsor each and every day of the STEM Summit. We cannot thank Philips enough for their leadership, their commitment, their support to young people, and wait till you see the cool work that they're doing. So in a moment, I am going to introduce Marie Poloni. She's Director of Talent Attraction and STEM Development at the Tech Council, and she is a resident nerd, a former teacher who loves science and loves learning, and you will hear that from her just not only today, but for the future. So we're very excited to have her here. So as I mentioned, I'm really excited to have Philips Healthcare here. We are going to learn more about their innovative, life-saving work in medical technology. Joining us today, Jennifer McHale, Product Manager, Craig Oates, a Senior Software Architect, and Gaurav Trivedi, Dr. Trivedi, a Senior Software Engineer. So we have students today, we have educators, we have them joining us from over 193 different educational institutions in our region. And all we want to say is thank you. Thank you for the work that you're doing each and every day. You're on the front line as we've gone through this pandemic, doing work that no one would have thought anyone would have done. And we really appreciate all the school staff, the administrators, the teachers, and fighting for students and families. We really applaud you, and we are here to do whatever we can. So just a little bit about the Pittsburgh Technology Council, just so that you know, we work to connect the talented and curious students across our region to our members who are all based in Pittsburgh for the most part, or have a presence in Pittsburgh, and they are technology companies. They're doing work that is changing the world. They're building solutions. And that includes across sectors of manufacturing and life sciences. So you name it, we get involved with it. Artificial intelligence, robots, natural language processing, people who are just doing incredible things. And we work really hard to make sure that our region is an amazing place for people to live, to work, to build their lives. And these companies actually recognize the talent that each of you students have. And they're very excited about the future, because the jobs today are not necessarily the jobs that existed even 5 years ago. So any way that we can keep you current and have close connections to these companies, that's what we're about. So I want to give thanks to Pittsburgh's community television, PCTV. This is not only being recorded, but it's also being simultaneously broadcasted. So actually live. So each day of the STEM Summit, it will be available also on demand, PCTV's website, along with our own website at pghtech.org. So now I am going to step out of the way, and I am going to introduce, as I mentioned before, Marie Poloni, our resident nerd, our resident science and math educator, and she's making all of us wise on our team, and you're going to have a great time hearing from her. So hats off to all of you for joining us, and Marie, take the baton and lead us through this.
Thank you, Audrey. You always do such a good job of opening the day. And thanks for PMI, who has had that great video for us every single day. Thanks to all of you for joining us. Today and every day of the STEM Summit, we really want maximum participation from all of you in the audience. So if you look down at the bottom of your screen, you again should see the hand, the Q&A. If you have any questions, go ahead and type it in. We will do our best to get to everybody's questions. Between myself and the student co-hosts, we're going to get those asked. Everything is really secure. No one will be able to see your name or your question except for us here as the hosts. Throughout the talk today, my co-hosts, which are students just like all of you, we have Nathan and Mike joining us today, are going to be asking questions that they have, but also some polling questions. When that time comes, they're going to post a question on the screen. Go ahead and either as a classroom, as an individual student, type in your answer, and they'll represent that for all of you. Before we meet the team at Philips, I want to introduce you to those student co-hosts. So we're going to start off with Mike. Mike, come on the screen. Talk to us about who you are.
I'm a junior in high school from Peters Township, which is south of Pittsburgh.
All right, and he has a question for everybody today. You should see it on your screen. Go ahead, Mike.
Philips has received national recognition and is ranked as the world's most innovative med tech company. True or false?
I don't know. I mean, it's pretty hard to believe that in little old Pittsburgh, we could have one of the world's most innovative med tech companies. But as the votes come in here, it's looking like most people are saying it's true. What do you think, Mike?
Yeah, everybody was right. The answer is true.
Pretty cool. I mean, we are really lucky to get to hear from Philips today and all of the innovation that they have. You're all going to be very impressed with really what is going on at Philips Healthcare. And then we have Nathan.
Hi, I'm Nathan Lamago. I'm a junior at Eden Christian Academy in Sewickley, VA. And my question for you guys today is, how did Philips ramp up its production of ventilators as the COVID-19 pandemic became a reality? And the choices are 500 per week, 2,000 per week, 3,000 per week, or 4,000 per week.
Great job, Nathan. Thank you. A couple more answers come in. All right, I'm going to end that poll and share results.
All right. Yeah, most people were right. The answer is 4,000 per week. Philips Respiratory, better known for its CPAP machines used for sleep disorders, started cranking up production of hospital and home ventilators months ago, doubling its usual 500 units per week after the COVID-19 outbreak emerged in China. With the virus now a global pandemic, they ramped up to 2,000 per week within 2 months, and now 4,000 per week by the end of the third quarter.
Thank you so much, Nathan. Thank you, Mike. If there is a polling still on your screen, you can go ahead and close it down. Nathan and Mike, as you guys have questions, please feel free to ask them. I am now going to pass the baton over to Monica Bush, who is the Senior Global Product Manager for Philips. And we're excited to have you here today, Monica.
Thanks, Marie. I could not express our happiness enough to have you invite us here today. And we're really excited to share what we've been doing at Philips and some of the careers and skill sets that we have within our team. And maybe Craig, if I can ask you to bring up the presentation.
It is on its way.
Awesome.
Yep. Thank you.
And maybe while we're doing that, I think most people, when they think of Philips, you might have some Philips products in your house. You know, you might have a Philips Sonicare toothbrush, or maybe someone in your family owns a Philips Norelco razor. You may have a Philips TV or some Philips light bulbs. And a lot of people are surprised to first hear that Philips does have a presence in the health technology space. A lot of products in hospitals like MRI machines, or I heard yesterday's STEM Summit was exciting, and you got to see a open heart surgery by Dr. Bailey. Some of those tools that Dr. Bailey may have used during his surgery could have been Philips tools. So I think it's interesting to hear kind of the various categories or places that Philips plays in, with medical and health technology being the strongest. And Craig, maybe if you can go to the next slide. Overall, Philips' vision is to improve the lives of 3 billion people a year by 2025. So you can imagine what it takes to be able to do that. and playing within hospitals and helping people who are hospitalized or maybe just discharged from the hospital or living with a chronic condition is something that is at the heart of what Philips MedTech does. And within our team here in Pittsburgh, we're the headquarters for the Sleep and Respiratory Care business group. And we develop innovations for people who have trouble sleeping at night, and that could be something like obstructive sleep apnea. So you may have, a family member who has to wear a mask while they sleep at night and has a machine by their bed because they have trouble breathing during the night. So that's one of the first products that Philips Sleep and Respiratory Care developed, as well as we have some other products that just came out recently that help people who snore or people who don't sleep as long as they would like to. We help them get a better quality of sleep, and we'll talk about some of those products later, as well as helping people breathe. So hospital-based ventilators, devices for people who have asthma or COPD are also part of what we do here in Pittsburgh. And as Nathan's polling question kind of referred to, because we help people who are having trouble breathing, and that is a primary issue within the COVID-19 virus, we saw an incredible need to really respond to what the pandemic that's going on, and ramped up our production. We even created a brand new to the market ventilator in about 3 months. Traditionally, to start developing a product and launching something, it takes about 2 years. And we crammed all of that timeline down to about 3 months and had a team working day and night to be able to deliver that so that we could make sure that we were saving as many lives as possible. And we have a nice little video here that talks a little bit about kind of the response to the pandemic. So let's take a look at that.
Every day, we work with you to fight this pandemic. Together, we build critical capacity for our healthcare system. Together, we define new ways to treat patients. Together, we serve those who serve us. But we're not done yet. Let's push this world forward, because together, we make life better. Innovation in you, Philips.
You can see from that video that the ventilators were mentioned, and the team in Pittsburgh had a role there. But there were many other groups across Philips that were standing up, emergency ICU units outside of hospitals and making sure people had access to telehealth. They could actually talk to their doctors, kind of remotely via their phones or via their webcams. It was just an incredible response from around the globe to be able, to respond as quickly as we could. And then just shortly from a sleep and respiratory care perspective, the company has been Pittsburgh based for 40 years, starting back in 1970 when we first brought to market a CPAP machine. And in looking at this timeline, you can see some of the other products that we have. We have, devices to help people deliver drugs if you have asthma. So if you or your family member, happen to have a nebulizer, it could be a Philips product. We have oxygen-based products. So if you need to be able to breathe better in your home, we have portable oxygen machines. And then other ways to support clinicians as well. And we'll talk about some of those products on the next slide here, just to give you a bit of an overview. We have, kind of CPAP machines that help people breathe better at night. And then our ventilation products that help people breathe if they're in the hospital or maybe just discharged from the hospital and still need support in breathing at home, as well as some of those portable oxygen concentrators. And then some of our newest products, if you can just go back 1 second there, Craig, thank you, are the Deep Sleep Headband, which is actually a pretty cool product. It's a headband that you wear on your head while you're sleeping, and it is has an EEG within it that is actually monitoring your brain waves, and it's looking for a certain wave pattern, and at that particular time, it is delivering some audio tones as well in order to increase the quality of that sleep you are getting at that period of time. So it's a really unique, cool product that I think if probably like 10 or 20 years ago, is something you could never have imagined would have been created. We also have some products, some mobile apps that for people who are having trouble falling asleep and staying asleep, we're giving you some kind of coaching on how you can sleep better. And then we have a snoring band. So if anyone in your house snores, they can wear a chest worn device that helps to reduce the amount of snoring they're having. And when you think about the type of people that we're helping, there's, people across the globe that we're looking at, and we'll look at some testimonials here from some of those people. So someone even like an Olympic swimmer may have sleep apnea, and you can see here that they're taking those machines with them all over the world. So we're making sure that anywhere someone is, and needs to be able to sleep at night, that they have the medical equipment with them at that time, that they're able to sleep better and then perform at their best. So obviously you can imagine how rested a Olympic swimmer has to be able to compete at that level. So we need to make sure that the products we make are able to meet their needs as well. And then the same thing, there's also, NFL sports players who have medical conditions like sleep apnea. And we need to make sure that the masks that people wear are comfortable, again, so that they're sleeping better and being able to perform at their best. And then finally, we've been able to help triathletes as well. So COPD is a condition where you're not able to take as much air into your lungs as possible. And it's pretty hard for me to imagine a triathlete having that condition and being able to compete. But this gentleman is, and we've been able to help him with the oxygen delivery systems that we have to make sure that, again, he is as staying as healthy as he can and being able to do what he wants to do and compete in triathlons. So from there, I'd just like to hand it over to Craig and Dr. Trivedi and Jen to give them or to share their experiences with their roles at Philips, what they do on a day-to-day basis and how they came to select the career path that they're on right now. So take it away, Craig.
All right. Thanks, Monica. Great introduction there. Hey, everybody. So I am Craig Oakes. I'm a software architect at Philips. And really, most of my background has been in software development, and have done a lot with systems development, systems design, and application design through my career. And I wanted to give you kind of a background of it. It was a long time ago, but it does not seem like a long time ago, where I was trying to figure out, what did I want to do and what things do I like. Over on the right here, I can see, I started programming at a really early age. I had no idea what programming was. Something I enjoyed doing. And this is not actually my setup, but it was a very similar setup on the Atari 800 computer way back in the day. Would be not a real fun experience to use today, but just tinkering and learning to do things. And I think for me, it was something that, I love building Legos. To this day, I love building Legos. I spend a lot of money on Legos and really enjoy them. And it's something I've been able to share with my family and my kids as well. And just tinkering, right? How do we lay out a breadboard, and can you pull power off a banana? Well, you can. I can actually still tell you how that works, but it works. And so just tinkering, playing around, being creative, just having fun, right? Just trying things, breaking things, and learning from it. So I tried that. When I graduated high school, I went on and went to Grove City College, just north of Pittsburgh, about 60 miles north, and went to college and got a computer systems degree. And really, that's where I really kind of realized how much I did like this and what I wanted to do and do this more for my career. But really, it just started with figure out the things that you like doing. There's a really good chance you're going to be good at because you like doing it, and just learn. The number of failures, the number of times I have frustrated is a crazy number, but you learn something new from every experience. And so I think that's would encourage you to do that. So I know a lot of programs you have in your schools. You may have different STEM programs where you're building NXT robotics, Lego robotics, or you're building things. I'd encourage you to dive into those and really go all in. Just explore the space. I'll give an example for my career. Of course, I'm with Philips. I've been a software architect with Philips for about 3 years now. But I've done a lot of different things in my career, and I'll just kind of, testimony to say you can do all kinds of crazy stuff. I've got to work with all kinds of fantastic teams across the globe. I've been able to write software that still flies off every new jet that leaves the tarmac for Gulfstream, right? So these really high-end business jets have software that I've written, and teams that I've managed and worked with that have built software that still flies today on every jet that leaves, every new jet that leaves. Got to go and do startup work with 360 Fly. So this was a 360-degree camera. It was a startup out of Carnegie Mellon Robotics. And, that was phenomenal fun, a great, Pittsburgh startup product there, right? At Philips, we've gotten to work on Smart Sleep Analyzer and helping to understand the needs of people's sleep patterns and help them find better ways to be able to sleep. All those products that Monica showed on a couple slides before can be really daunting for people to understand, well, which one's right for me and what is the problem that's keeping me from sleeping. And this is a tool to really help people with that. And we've kind of looked at this in Australia and the United States, and Philips having a global presence, really exciting time to be able to take things and have a massive footprint and have a huge impact. Gotten to work in cybersecurity and do identity theft management and help people who've had their identities stolen and help people keep theirs from being stolen. And I've gotten to work with a whole host of our kind of finest Air Force, our finest federal and defense agencies. So I've spent a lot of my career in aviation and defense, working with the Army, the Air Force, the Navy, Special Operations Command, Strategic Operations Command, and Department of Veterans Affairs, and several others. Didn't have enough room on the slide, but I mean, it's a really interesting space. And I think I'm just want to throw out there that if you are in the STEM field, there's crazy number of different things that you can do in your career, and in what you things that I never even dreamed existed. You're able to kind of dive in and make an impact in. And some of the skills and technologies, I wanted to kind of pass along some of the things that I look at and that I work with on a regular basis, and that I've worked with. Different languages. You may or may not know what these are, but I'll throw them out there in case they resonate. I mean, so you've got .NET Core or Java or Swift. You may recognize some of these different programming languages. On the web side, you've got Amazon Web Services, HTML, JavaScript, Angular. On the mobile side, you've got Xcode and Android Studio and Unity. these are all just different tools to create some of those things that we saw there. And as you, as you learn about these things, you may learn one of those. You may just learn Java, or you may just learn .NET Core, or you may just learn how to do iOS development. And I say just because you've got to start somewhere. And there's all kinds of great places to start if you haven't started already. There's a couple of resources across the bottom of the screen here: code.org, Hour of Code, Scratch, Alice. These are all different frameworks to kind of get up and running. And these are really just the start. So if you've done these before and looking to go more advanced, again, I'd encourage you to get more involved. If you've never taken a step to say, how do I get involved, and what's programming look like, and to something I'd even think I might like, go check it out. I'd encourage you, go to one of these sources, talk to somebody that does this, talk to a teacher or a peer, and dive in and check it out. You owe it to yourself to see if it's something you might want to do. So I can say for sure, for me, it's been an amazing career. I've been able to work with some phenomenal people. I've been able to do things I never dreamed of doing and never even knew existed again. So it's been really a fun time. And yeah, so I would just encourage you to find that spark that you've got in curiosity and explore it, see what else, where it might lead you to. So thanks everybody for coming out and hearing us, and hopefully get to hear some more fun folks here from Philips. I'll turn it over here to Dr. Gaurav Trivedi next to walk you through some of his experiences.
Sure, thanks, Craig. All right, so that's me. I'm Gaurav Trivedi. I have a background in applying artificial intelligence for healthcare applications. So that's a picture of me getting overwhelmed by the problems that computing systems cause in the ICU. I know some of you who were there. I just learned that you guys had a chance to see how an open heart surgery was done. So I was completely overwhelmed when I had to do some of that work to understand how physicians use AI, primitive forms of AI and computing in their workflows. And it's a very exciting field. I would say it's exciting because I would stay on the same slide, Craig. It's an exciting field. It's interesting because it has a lot of problems. And it's always good to be in a space where you have so many things to address and to solve. And we're not going to solve them very quickly, and we probably need more help. So you guys should be looking at these fields, looking at this problem of using technology and artificial intelligence in healthcare. And I'm kind of lucky and sort of very happy that I get to do that on a day-to-day basis here at Philips, where we design innovative products and services, where we build in AI, and we build in systems for not just for consumers, but also for clinicians and providers and payers and that whole spectrum. So I'm very lucky to be able to do that. Now I can walk on to the next part, continuing with what Craig was telling you about how you should think about things that you're excited about, what makes you doing fun things. So this is how I got started in computer science. You guys probably have a lot more cooler things to play with. We used to have this program, this software language called Logo, where you would give commands to a turtle on the screen, which you see, and you could make it go up and down and go forward and steps. You would specify go forward 10 steps and so on. And I still remember when I first did this, if you want to hit play on this video, Craig. Yeah, I still remember when I first tried doing this, where you could write a loop and you could make the turtle go one step forward, one step right, and it drew a circle. It should just show up on your screen. And I was amazed when that happened. I was like, oh, wow, that's amazing. And that was my first vivid memory of how programming works. And I was completely hooked onto it. And I've always been sort of this proponent of using CS as fun sort of methodology. So I've always sort of tried to pursue things that I play with and use computer science to either tinker with it or try to reinvent them and build some new stuff. So the next one is another example from my undergrad, where I was interested in playing air hockey, and I wanted to hack a system where you had a mix of a virtual system and a real system. So we had a real mallet. Mallet is the thing that you hold and hit the puck with, and everything else is like virtual and projected onto your table using a sophisticated contraption of a projector and an array of mirrors. So from underneath the table, you would be projecting the air hockey table, which is all virtual. But you had the mallet, which is sort of physical, and we had designed this hardware ourselves. We had a little motor inside, so if you hit the puck, it would vibrate and you'd feel that sensation. But what was interesting to me was the AI component in it. So we had this camera system monitoring everything on top, which would sort of figure out where your mallet is and simulate that behavior onto the virtual thing that has been projected. And that was my sort of first exposure on how to build these computer vision and AI systems. And it was super cool. My school actually let me keep this table to students for like 3 days, and then they took it off. So students could play around with that system for 3 days in the school. They didn't want to maintain it, so they took it apart. So that was one of my introductions to AI. And if you move on to the next one, is another sort of fun example. I play this drum called tabla. It's an Indian drum, and it has a language to it. So I'm going to mispronounce this word. It's called onomatopoeia or something. Yeah. So what it means is that the language basically sort of imitates the sound it sort of represents. So if I'm supposed to say the word dha, that's the sound that I'm playing on the drum. So each word stands for the sound. So that's the language of tabla. And now I was kind of intrigued by that, and I was interested in doing applying some of the things that I was learning in graduate school in natural language processing to be able to generate these rhythm patterns automatically and play. So it's like an AI playing rhythm. And I did this a couple of years ago when not a lot of people were doing this. Nowadays, it's a very common thing. In fact, Google just came out with something last month. So when I did this was a new thing. I posted it on my blog, and it got featured on some Hacker News website, and it crashed my blog because so many people were visiting it, and I was surprised. You can try it out. I have a link there if you want to try it out later. But the interesting thing is that some of the things that I was learning doing these interesting projects is what I directly did for my work. So if I'm working in healthcare space and I'm trying to build models and machine learning systems for understanding what the clinicians write, building models for understanding clinical language, I was just using the same kind of tools and techniques that I was learning by doing these fun projects. Craig did give you some resources, but if you just sort of Google CSS Fun, in fact, there's a website called cssfun.com. You can find a whole array of resources, whole array of tools where you can start building some cool, fun play things and learn actual computer science. So that's something that I thought I would share. Yeah, that's pretty much everything that I wanted to present. I would hand it off to Jennifer McHale for the next part. Ooh, that's a demo. So believe it or not, this is a composition which was completely generated by AI with no input. I gave it a little bit of a seed, which is like, hey, this is how I wanted to start. And everything else it came out on its own. So it's sort of creative in its own right. And I did it by learning from past compositions, which I fed a database of rhythm compositions. All right. Thanks, Craig. I would have forgotten about that.
Hi, everyone. I'm Jennifer. Like Craig, I started with Legos, with liking engineering and just being able to build something and see that end result. Also, just quick tip, if you're not good at spelling, most engineers aren't. So if you're not good at spelling, you should totally become an engineer. So again, you start with Legos, and then moving forward, you kind of find the Legos as you get older and finding things that you like and things that you're good at. And combining those two, you can kind of find your little niche and what you want to look for in a career. So it could be, can you go back, Craig?
Oh, yep.
Sorry. So it could be something from a school project that you get interested in, and then you can do more research. Also, I would suggest looking at what your friends and family do for their jobs. I know I didn't know what my parents did on the day-to-day basis for a long time. So just Google what their job is and try to see what do they do. And then even within that, there's a lot of different variants. So I grew up in New Jersey. So I went to Rutgers, which is the state school of New Jersey. And then I came to Pittsburgh for grad school because there was still a lot about bioengineering, which I wanted to know. And so I did bioengineering at Rutgers, and then I still wanted to learn more. So I went to Pitt for grad school to learn even more about it. And so again, I was saying for school projects, one thing I built was a hovercraft in high school. You can see it there. It did work despite what people thinking it would not work, but somehow it magically did, and the magic was science. Next one. So different types of engineering. There are a ton of different types of engineering that exist. And so basically any type of thing you want to look at, there's an engineering field for. So anything that's built around you is an engineer had some part of it. And so the most important qualification, just as a quick question, a non-official question, if you can think for a second, what's the most important qualification for STEM career? Greg? Or interest. So if you can show an interest in some type of building, in anything, basically, how it's made, take a step back, that's your engineering field to look at. And so these are all different types of engineering. And these are actually all different types of engineering that my friends are in. And so as an engineer, your first 3 semesters about in college are identical. And so you start out taking classes with people who are interested in completely different things from you. So they might be interested in chemistry and becoming a chemical engineer. They might be interested in mechanical engineering or industrial engineering or civil engineering. So starting with civil engineering as an example, civil engineers, they build bridges, roads, buildings. And my friend loves bridges, and she's always loved bridges growing up, and she's fascinated by them. And so she was studying to be a civil engineer. And this bridge on the bottom left, that's a real bridge. And she actually built that and designed that. So I went to school with her. We had classes together, and then our careers split off and our interests split off, and she ended up building that bridge. Another friend of mine, again, same classes to start out with, she became interested in mechanical engineering, and now she's in charge of controlling some of the US satellites. Other people, and another friend of mine, I worked in industrial engineering, and industrial engineering is about improving efficiencies in factories. And so they actually work for Nabisco, and they work with Oreos and Chips Ahoy and making sure those systems are more efficient. Another friend works for the government making physics simulations, and I think it's for actually missile systems. So seeing almost kind of like what Gaurav was talking about, where you develop a system that has some artificial intelligence components to it that will behave in a way that it would in the real world. And so you can simulate what will happen exactly and precisely before you actually do it, which can save a lot of costs and eliminate a lot of errors beforehand. Another one, the final on the right I have there, is a multi-unit neural spike sorting using discrete Gaussian approximation of a Bayes classifier. So basically it's detecting neural spikes. And so from that, you can track what the brain is doing and link it to a specific action. So even within, starting out as a bioengineer, even within bioengineering, there's a huge degree of variance in what you could do. So Gaurav and I both studied bioengineering at different points, And we do very different things now. And even in my own pathway as a bioengineer, there's a lot of different variants. So there's things from prosthetics, so improving prosthetics and trying to take those neural signals and turn them into a movement. How can we do that faster and more efficiently? Improving surgeries. I know you saw a open heart surgery yesterday. I got to see one too when I was in college. And when we were watching a surgery for an infant, and so it was very sad but also very inspiring. The doctor didn't have a device that existed, and so he actually made a device in the OR during the surgery for the infant, because no device existed. They needed to grow a little bit bigger, and then there would be a device that would work, but they couldn't. It seems like surgeries are already perfected, but there's still a lot you can do to improve. Another one, a venipuncture robot. So if you've ever had to get a needle and they missed, it's not very fun. Some people have very hard veins to find. And so the venipuncture robot actually would use imaging techniques to figure out where your vein is and inject a needle, so it could be more accurate. And you can get, for people with tough veins, you don't have to get stuck with a needle a bunch of times. For orthopedics, that is, anyone want to guess what it is? You can think about what could that be for. Give you a second to just guess in your groups. And the answer is, it's a spinal orthopedic. So in between your spine, if you have a little bit of cartilage and that becomes decompressed through many different reasons, that would go in between the discs and secure your spine. Another one's rapid diagnostics. And so you have a lot of you always have different boundaries for engineering, and you have different requirements. And so you have to design within those requirements, and it kind of can be inspiring and it can be fun. And so if you're in a low resource setting, or if you're in different climates, you have to design differently and for different people. For orthopedics, again, with knees, they originally had knees for just men, and now they design them for women as well. And so they have different sizes now. So you design based on different constraints. And so all these projects are actually things I've done either in school or working. Just another one, pharmaceutical packaging. I did that for a bit and realized I didn't like it. And I would highly recommend getting internships and trying out different things. And then you could really find what you like. And so you can test and say, okay, do I like aerospace? Try that, see if you like it. And if you don't like it, and you can move forward. And if you do love it, then you know exactly where you're supposed to be. And for me, I ended up falling in love with a different problem. And so all these, for engineering, you kind of fall in love with a problem and work on building that solution. And so my problem I found was people, and how can I engineer people to help them help themselves? If they're having sleep problems, how can we figure out, okay, what I worked on Analyzer with Craig, and how do you figure out what problems that you have, and how can we figure out how to help you, and what do you need to do to help you? So trying to bring the right people to the right problem.
So thanks, everyone. We hope you really enjoyed learning a little bit more about Philips Health Tech, as well as some of the kind of career paths that we have within our group. And maybe it helps you to think about a little bit more about what you would like to do in the future and what you'd like to get involved in.
That was absolutely so dynamic. I think by far this has been the most diverse team as far as the roles that you play within the company, and that was really fun to see just all of your different backgrounds and what you came in with. We do have some questions from the Q&A, but I just want to make sure first that I give Nathan a chance. Mike actually had to step out and go take a test. I mean, my goodness. But Nathan, do you have any questions before I ask from Q&A?
I have one. So for each of you, like how long just have you guys been at Philips?
That's a great question. Do you want to start with that, Monica?
Sure. So I've been at Philips for about 5 years.
I've been at Philips just about 3 years. Let's say 2 or 3 quarters.
Yeah, I just completed just over a year now. Just last month I completed my first anniversary. But I went to school here in Pittsburgh where I did my graduate work as well. So I was working on very, very close to this office space and also in very similar fields.
I started working at Philips while I was in school as an intern, and so I've been here about 3 years.
Thank you.
Do you have any other questions, Nathan?
For two, I might have missed it, but where did everyone attend their undergrad?
Sure. So I went to Duquesne University here in Pittsburgh.
Okay.
Yeah, I went to Grove City College.
I did my undergrad in India. It was a school by the beach, so I like to flaunt that. And I did my master's and PhD at University of Pittsburgh.
I went to Rutgers University in New Jersey.
That's all of mine. I enjoyed it.
Thank you, Nathan.
Yeah.
Some questions from the audience. Did Philips have any role in the telehealth response that we've all encountered?
Sure. So another part of Philips had a really big role in creating remote kind of ICU environments. So they, given the transmission of the COVID-19 virus, they had to figure out the problem that was happening was that, physicians had to treat their patients, but did not want to necessarily have exposure to the virus. So they were trying to, the problem they were solving is how do I have the physician engage with that patient, but not necessarily be in the same room with them where they might contract the virus. So there was some work done around being able to create a telehealth environment for those interactions to be able to take place. So both patient and physician could engage together, but not necessarily be in the same room. And now, because of that success, I think telehealth is going to be much more prevalent. You're going to see that a lot more with engaging with your own doctors even. And we're now looking about how we apply that into the sleep environment. So some of us are working on some projects looking at sleep physician, working with sleep physicians, and the way they engage with patients today might look a little bit different in the future. You may no longer have to physically go into an office to take a sleep test or to have your face-to-face visit with a doctor. You may be engaging via telehealth much more and being able to actually use a home sleep type test to be able to identify, your sleep problems as well.
Wow, that is amazing. When Carlin asked, when ramping up production for the COVID-19 pandemic, how did that affect your hiring and workforce? And what skills are you looking for in new hires?
Oh, that's a great question as well. So I would think specifically for the new ventilator that had been built so quickly, there were a couple of different skill sets that they were hiring for. Mechanical engineers, software engineers, I would say more and more looking towards the future. We'll be going towards more software type development projects, as well as, they needed people on the manufacturing lines. So the manufacturing lines, were running 24/7 in multiple locations. So they were looking for people, for skill sets to make sure that 4,000 a month production or a week production could actually be hit, so that we could get them to the people that needed them. We could help the patients get better. So there was definitely a whole host of different skill sets and roles involved in getting that product to market.
And that is pretty exciting. And I know that you're still looking to do that too. So everyone needs to keep their eyes on Philips for sure here in Pittsburgh. The last question before I hand it over to Audrey, McGahee wants to know, what advice would you give to students who start working on a project and encounter obstacles and just want to give up? As an engineer, how do you handle such obstacles? And this is a great question for this group. I think we heard different things throughout the presentation.
I could take that from a software engineer perspective. I always do find problems, and Google is your friend. Even after doing also that much school, you still have to use Google every now and then. In fact, every time you program, you Google for things. So you have a lot of resources online, you search for things. But having said that, we are also part of an advanced innovation group. And our job here is to try out a lot of new things. And not a lot of them would succeed. So at some point, you need to be able to figure out, okay, I have tried it enough, and let's move on to the next thing. This one is probably going to come back to this later, or we will just shelf it in some sense. So we need to be mindful of that too.
I think,
oh, go ahead, Monica.
No, I was just going to say, I think one of the great things to do always is when you are feeling frustrated and maybe can't get through that problem is remind yourself about who you're solving the problem for. So think of that patient or that end user and what they're experiencing, that problem that they're having. And that sometimes helps you keep going as well, knowing that you're truly helping them solve a problem and that they need you to help them do that has helped kind of get through that frustration as well.
So one thing I found really useful is looking at other industries and other engineering fields to try to find more information and more potentially options for solutions. So in prosthetics, for a lower limb prosthetic, which is like a knee joint, they actually use some material that was first used in trucks. And so in the truck seat, they have a particular, in the truck, I think it's in the brakes, they actually have some materials which then they use in the medical field. And so just looking at other industries, see what they're doing, what they're using, and seeing what else can I use that for.
Yeah, and I would throw in one other thing. So I think this is something that we absolutely, everybody who's been in engineering, and probably much outside of engineering as well, struggles with. I mean, you're gonna hit problems. I mean, engineering is not easy. It's just not easy, and you're gonna get frustrated, and you're gonna find you're in an impasse. I think just in a practical stance, take a deep breath, take a step away from where you're at, and ask for help. I mean, I think that's probably one of the hardest things, one of those practical things there, is ask for help. It's perfectly okay. There's a really good chance that people around you, people you're working with, Stack Overflow is your friend. I mean, take a step back and use the resources that are there. There's a lot of people that want to help you. They just don't know how. And so you use that help. And just keep in mind, I think that perspective is really good as well, of just knowing, like Monica said, keep in mind the people you're doing this for and the pain points that it's going to solve, and persevere through that. So I think we've all hit really big obstacles, really big things. And I think that challenge is, when you're in the middle of it, is really frustrating, but just use those resources. I think that's what I would encourage you to. Don't be afraid to ask for help.
Thank you so much for all of that. And thank you for being here today. I'm going to pass it over to Audrey to wrap us up. But Philips, thank you so much.
Oh, yeah. I thank you, Marie. Thank you to everyone that joined us from the Philips team here. I took away so much. I always think that I know a lot, but every time I hear one of these and get a chance to do a little bit of an inside peek, I'm actually more than impressed, because Philips' presence in Pittsburgh came from an entrepreneur that started in the 70s that was focused on sleep apnea way before the issue of sleep was sort of as everyone talks about it today, was not talked about back in the 70s. And they had a vision, and it was called Respironics, and Philips acquired the company and continued to do that work. So it's a remarkable story, and it is one of Pittsburgh's really prominent successes. And so to see the kinds of people that are working in that company now and to listen to all of you was really so reinforcing in terms of what it's like to have a career and have an impact. And you're all doing it in your own way, whether it's fun, like what we saw from Gaurav, where he's doing, working in natural language processing and artificial intelligence and creating drumming and doing fun things to build his own skills, to understanding the customer and understanding human computer interaction and putting the customer first. Just there were so many things that I'm really in awe of, and the diversity of the skills. I think, like what Marie mentioned earlier, this is the widest range of opportunities that one could have and think about. So if you want to go into engineering, there's so many, diverse pieces of that. But also, I think the whole notion of building stuff, I think as Jennifer started to talk, gave all these examples. I didn't realize I could work on the line and deal with cookies. I mean, you could deal with cookies. Your friend who has that job, giving everyone an understanding of that, but also focusing on healthcare and, work that Philips is doing. All of it builds the necessary skills that you need to have an impact, and you can really have an impact. And I am just really blown away by the candor and the time that you've shared with us today, Philips. We're gonna, like I said earlier, one day it'll be real time and we'll all come and visit you and we'll get to spend some time. But for now, I can't thank you enough for just taking the time with us here, making sure that I can't thank PCTV for doing this simulcast with us, and for Marie for being a good leader and convening these subject matters, because it's really important to both educators, to parents, and to students. And during this period of time where perhaps the access to businesses aren't as high, and we need these kind of interactions. So thank you. Thank you to Philips again for being our sponsor for all these days. We have one more day left. I want to thank Shell Games and Huntington Bank so that we could make all this free to our educators and students. And tomorrow we're wrapping the week up of, well, actually it's 9 days. We're wrapping the week up with the Explorer from Rivers of Steel. So stay connected to us, Pittsburgh Technology Council. We're here to serve all of you. Thank you to the team at Philips. We're going to stay in close contact. And thank you to all of you who have joined in today. Have a great day and stay safe. Thanks, everyone.